the homework problem, they actually don't say, are they orthogonal? It actually says, are they orthogonal, parallel, or neither, right? But there's no examples that talk about whether or not two vectors are parallel. Remember, most of the time we're dealing with straight lines. We say that two straight lines are parallel when they never intersect, right? But vectors, remember, they don't have a position. I mean, you can move them around anywhere. So for us to say parallel, what we really mean is they have the same direction. They're not necessarily that they wouldn't intersect, because they don't have position. That's not really a good question. Is that, do they have the same direction? And do you remember when we did the very first example in the last class, and we were just looking at two directed line segments, and we calculated slope, right, to determine whether or not two vectors had the same direction to them. Well, in this case, if you did the slope with the components, it'd be like saying 45 over 15 would be the slope of this vector, and 12 over negative 5 would be the slope of that one. So you could compare that, right? You could say, is 45 over 12, or sorry, over 15, is that equal to 12 over negative 5? No, right? It's not. Clearly, one's positive and one's negative. But you could also, if you don't want to do it that way, because it still have to be the same thing, you could say, is 15 over negative 5 equal to 45 over 12? That's also a good check for being parallel. In either case, you're going to say no and no, which means not parallel. That's too many L's there, not enough L's there. Okay, now what's the check to whether or not they're orthogonal? Do the dot product, right? So we'll do 15 times negative 5 plus 45 times 12. What is that? It's not 0, basically, is it? And that's the only thing that matters. What is it? It's 365? 465? 465, right? Which is not equal to 0, so we say not orthogonal. So that's the orthogonal part, that was well covered in this, but the parallel part, that wasn't really addressed, but that's how you could tell whether two vectors are parallel.